Hey everyone, my name is Ranshu, and today I'll be presenting our team's submission for the high school challenge. And so my teammates are Charlie, who is also present in the meeting with us, and my other two teammates, Janet and Ingrid, are unfortunately in a different time zone and thus will not be able to attend this Zoom call. And so basically our submission is focused around the idea of multimedia enabled drone applications. And basically we want to address the idea of sustainability in developing countries. And so we combine these two ideas. And so basically our presentation is going to be talking about how we can use multimedia enabled drones to help prevent biodiversity loss, specifically hunting of at-risk species in different regions around the world. So first of all, we must ask ourselves, what is the main purpose of sustainability and how does it tie back to our topic? So first, we have to consider that sustainability is the process in which a country can actively develop or improve their circumstances while maintaining the amount of natural resources that they have, not depleting them all, so that future generations have the ability to continue thriving. So the major problem at hand is that developing countries, so basically third world countries, often struggle with a multitude of problems that lead to them depleting their natural resources faster than expected. And so some of the issues that cause this are poor sanitation, large amounts of pollution, a lack of drinking water, contagious diseases spreading rapidly, and a lack of infrastructure in their societies as a whole. So what we are proposing is that we want to use different multimedia techniques to help solve these problems. And a few examples that we will talk about are drones, which are basically aircraft operated without human pilots on board, which will carry heterogeneous sensors, so cameras and microphones. And they will use these tools and techniques to try and aid sustainability to the best that they can. The major challenges facing sustainability are, but not limited to, climate change, soil exploitation and degradation, biodiversity loss, and pollution. And as for our project, we've decided to focus on biodiversity loss, specifically illegal hunting for at-risk species. The usage of multimedia-enabled drones, in our case, can help inspect areas with volatile environments, specifically tracking poachers who may be hunting at-risk species. Besides our scenario, there are also multiple uses of multimedia-enabled drones that can help benefit society as a whole. For example, in smart agriculture, in which multimedia-enabled drones can help farmers analyze the viability of their soil over years, and also their crop yields per year. Another possible usage for multimedia-enabled drones would be in the medical field, in which they can help deliver necessary medical equipment, like, for example, blood or vaccines, to places in urgent need of it, cheaper, as drones are cheaper than actual transports, and more efficiently, as the drones have the potential to be able to travel in highly unstable areas as opposed to regular forms of transportation. So this slide will talk about how we can use these drones to actually save animals. And so first of all, I want to take a quick moment to explain and discuss the existing efforts that are in current usage. And this is through Air Shepherd. So basically what happens is that they fly drones in high-risk areas and they send data to operators at the ground. And these operators will then be able to analyze data and thus determine areas which are at higher risk, and they can predict incoming threats to wildlife. And so the main challenges of this currently are that there are pilots for these drones, and they're responsible for the physical aspects. So they have to launch, they have to recover, they have to navigate these drones. And another challenge is that there constantly has to be operators at hand, because without operators, there's no one to analyze the data, and thus there has to be someone basically at this operating station 24/7. And another challenge currently is navigation in diverse terrain, because of course there are many different terrains that one have to manage. For example, maintaining a drone in, for example, Nepal is much more different than maintaining one in Kenya. And because of this, pilots and navigators and operators are required to be able to adapt quickly. And lastly, the biggest challenge would be the cost, because through this method, you have to maintain a command center and you have to train local people to be able to undertake these operations. And on average, it takes 4 months for them to learn these roles. So historically, there have been several simulators in which different people have tested the viability of this, of basically multimedia-enabled drones. And so the first would be Bondi et al. And basically what they did is they simulated the use of drones to identify poachers hunting wildlife animals in an African savanna. And so the main difference is that they use thermal cameras to basically track heat sources, because elephants are probably the largest heat source in savannas. And they use computer vision to identify and to confirm that these actually are elephants. And then they use an API code to basically follow these elephants around. And so what they did further is that they observed differences between existing and the proposed algorithms. So the original is known as iSpy, and it was later discovered to be problematic, and it couldn't compete with the proposed algorithm, which is called SPOT. And this is the main reason is because SPOT utilized a faster CNN, which stands for convolutional neural network, and this allowed SPOT to run with greater efficiency and was much more effective than iSpy as a whole. So as of now, the current Airsim script, it works as follows. So first, it will connect to Airsim. It gets a list of the basically the entities present in the simulation. So for example, the ones in our simulation would be the poachers, elephants, crocodiles, and hippos. And it will next follow one of the objects to basically kind of get the precise location, and they do this by it's a method called the simGetObjectPose, and it will continually capture the RGB or IR images for a preset duration, and after this duration, it will then move on to the next object, and the process repeats over again. And so basically what we propose to do is that we will link Airsim to object detectors, and then we will propose an algorithm basically for the drone to follow the elephant herd around, and then we will propose another algorithm for basically other drones to locate poachers that may be nearby this elephant herd that we are now locating. And so the main purpose of this is that we can track the movements of elephants and we can prevent poachers from getting close to them.
Our tracking algorithm aims to maintain the drone's position at the center of the elephant horde. So first, we assume that 0, 0 is the coordinates of the center of the image. Then, using machine learning, we draw bounding boxes around the elephants. Now, if we take the center of the bounding boxes and assume that that is the coordinate of the elephants, we can find the average coordinate, which is just all the coordinates added up and divided by the total number of coordinates. After finding the average of all the coordinates, we now have the center of our elephant horde. Using the center of our elephant horde, we can use relative bearing to maintain our position in the center of the elephant horde instead of just staying in one position. Our second algorithm is the routing algorithm. The routing algorithm aims to visit the expected locations of all poachers within the limited amount of time. This algorithm assumes that the drone is flying at a constant speed, s. Our routing algorithm is quite simple. First off, we create a list of all the poachers' locations and we sort them by nearest to furthest relative to our drone's location. Then we simply visit each poacher in order of the list. Then we repeat this process over and over. There are other ways to approach this problem, such as using brute force to calculate all the possible permutations and then find the best solution. Or you can also use the branch and bound method to also find the set of solutions that is the most efficient. However, these solutions are unrealistic as they take time to compile. The nearest neighbor method, which is the method we used, is simply much faster than the other methods, allowing it to be the most ideal for this situation. Throughout this project, we have used a Microsoft Windows 10 PC while also using Airsim version 1.5.0, Unreal Engine version 4.2.6, and YOLO v5. Here are some screenshots from our simulations. The picture on the left top shows that YOLO v5 can identify that the elephants are an object. However, because this YOLO v5 model was not trained by ourselves, it doesn't recognize that the elephants are elephants, but it rather sees the elephants as birds. The pre-trained model we deployed was not trained to identify elephants from a top view, so it failed to recognize the elephants. On the right side, we see that there are poachers on the floor. However, YOLO v5 failed to identify these poachers because of their similar color to the dirt. Of course, through further implementation, we could train a model that could identify the poachers. Before we show our simulation results, we would like to note that there were simulation regulations. For example, we repeat each 90-second simulation 5 times. Some things that you should be watching out for are that we vary the drone speed in certain evaluations, such as the tracking algorithm evaluation. So please look out for that. Here are our routing algorithm simulation results. In the first graph, we can see that the larger the drone speed, the more it overshoots. This could be because elephant herds do not travel at high speeds. The second graph shows the remaining poachers over time. Now, the poacher numbers are randomly generated, meaning that the amount of poachers from the beginning is not consistent. However, we can see that our algorithm finishes all 4 poachers in about 16 seconds. The final graph shows the total visited poachers throughout the 90 seconds. We can see that our algorithm works much better than the random or the sequential algorithm. Here are our tracking algorithm simulation results. Before we begin, let it be known that the error bar represents the minimum and the maximum across the 5 runs. The first graph shows that 0.4 mirror/seconds gives us the most amount of elephants visited during the 90 seconds. Our second graph calculates the average deviation. In this graph, we can see that 1.6 meters/second is way too fast for the elephant herd, and that 0.4 meters per second seems to be leading to the smallest deviation. Our third graph shows that our algorithm allows us to visit the most poachers throughout the 90 seconds. Lastly, we have our fourth graph. This bar chart shows that our algorithm takes about 37 seconds to visit all existing poachers. However, both random and sequential algorithms take almost 60 seconds on average. Note that we set the lap time to 99 seconds if any algorithm couldn't finish all poachers before the simulation ends.
So basically, in conclusion, first I'll address what we actually have done in the project. So here are several key points. So we have designed and implemented a strategy to improve security measures for endangered animals. We have developed algorithms in order to optimize drone usage in less developed areas. And we have identified several problems, and we have proposed our solutions to them. We have attempted to create solutions using minimal human interactions and minimal costs through embracing the idea of multimedia through simulators like Airsim and Unreal Engine. And we have also taken into consideration the local communities, and thus we have tried to make these projects as sustainable as possible. So what can we do in the future, and what are some further possible things? So we can obviously improve our algorithms to make them more efficient and to optimize their performance. We can retrain the yellow defect model to basically recognize objects that are commonly seen in less developed areas and to better allow the model to view objects from a bird's eye view. And we can also use different multimedia sensors like acoustic sensors to hopefully optimize some of our algorithms. And we can also increase the economic, political, and social impact that multimedia and this project in general can have through legislature, social media awareness, and even negotiations with corporations. And so here's a really quick infographic of basically the three things that influence this project the most: political influences, social influences, and economic influences. So firstly, social influences obviously are important because they spread awareness. And so basically the main problem we're tackling here is basically biodiversity loss and basically sustainability loss as a whole. And one thing that we can do to help is to raise awareness around the world, because a large part of this problem is caused by ignorance or basically apathy towards this problem. And so several factors that play a key impact of social influences would firstly be the public, of course, because the public is what social influences create, and social media, because social media is a very powerful tool in spreading messages, and lastly, celebrities or influencers, because these people have the followings and the actual power to get messages across. And obviously, economic influence is also a huge part, and that's mainly because companies have financial incentives to either help or basically destroy sustainability as a whole. And so what we need to do is we need to basically propose to companies solutions that can continue to promote sustainability, and B, allow for companies to earn a greater margin of profit. And lastly, the last influence would be political influences, and this is when we can communicate with areas where sustainability is basically not effective, and we can talk to their local government, local politicians, and have them create legislation or enact laws that will help promote sustainability as a whole while minimizing the cost for local governments.